Hello guys, you're welcome back to Staad.Pro. In today's class, we'll be doing slab design, slab reinforcement design with RCDC. It's going to be a concrete design where we provide reinforcement for the slab and thickness of the slab will be determined, will be checked also. Then we take our slab detailing to AutoCAD. You will know how to take your output drawings from Staad.Pro RCDC to AutoCAD, and from AutoCAD you can dust it up and it becomes a detailed drawing. So today's class we are going to cover slab reinforcement design. Stay tuned, and if you have not subscribed, I will urge you to subscribe and stay to the end of this class so that you get everything about slab reinforcement design and detailing. Okay, this model is a duplex that we started in this our channel. We modeled everything and it has been loaded as well. So if you look at the loads, we have the primary loads including the wind load, and we also have the combination load cases according to Eurocode. So we quickly run analysis. We have done all the checks and everything was okay. So we just run analysis again. Like I told you before, each time you close your Staad.Pro work and you are coming back to do a design, you have to first of all run the analysis again. You have to rerun it so that the system will get the reaction forces which it will apply to whatever you want to design. Now that you are done with the analysis, as you saw, there was zero error and zero warning. So we proceed by clicking on Advanced Concrete Design. So this is the software. It has a standalone, but since you have the model already in the Staad.Pro, just click the icon here. It takes you directly to the software. So I'll just click on it. Then you wait for it to come up. Yes, this is the place you need to put the project name, what you are working on. What's the project name? For me, I can just put duplex. And what's the name of the client? Say Mr. ABC. Then what's the name of the engineer? You put your name there, engineer XYZ. Yes, under this one, you choose your code. And let's use the European standard in Eurocode. Choose 2004. So then we have to check, select what we want to design. In this case, we are designing slab. So we just select slab. So it will give us different levels of the structure. We have level 00, which is the ground level. So you have to use these levels to determine, to tell the software where the slab we want to design is located. So this one is the first floor at 3 meter is the first floor, while at 6 meter is the roof level. So the slab we are to design is at the 3 meter level. That's the first floor. Then I'll click on create project. It's very simple. And you wait for it to come up. That's that. So if you look at the drawing window here, the slab layout is already drawn by the software. You can see the panels, the two-way and one-way. See the two-way, the one-way, this two-way, one-way, two ways, one way, two ways, one way, two ways. So the panel, the slab layout has been designed. Of course, you should know how this one way and two ways came about. It is called the aspect ratio. When you divide the LX over LY, if it gives you a value, up to 2, then is a one-way slab. But if it gives you a value less than 2, 1 point something, then it's a two-way slab. So if you come to this other side, you see our panel number. Anyone you click on will be highlighted with red over here. That's it. So if you look at panel number 1, see LX is 3.72, LY is 3.73. So how do you know it is a one-way slab or two-way slab? Just say LX, LY over LX, the longer span over the shorter span, as a 3.73 over 3.72. So this is 1.0, so it's two-way slab. So if you check it, see it's two-way slab. So that's why it's two-way. So let's see this one that is one way, which is panel 7. LX is 2.2. So if I get my calculator now, you see 6.12 divided by the shorter span 2.29 is a 2 point some. So once it's up to 2, is a one-way slab, one-way spanning slab. That's how it came about. So if you are doing your slab layout by yourself, you should now know which one is one way and which one is two ways. That's clear. So if you come back to this panel number 1, you see it's two-way. There's two adjacent edges discontinuous. So if you look at what they mean is two adjacent edges, this edge and this edge. This edge is adjacent to this edge. They are discontinuous. So they are not continuing, as you can see them there. So it's very, very understandable. When you come to this one long edge discontinuous. So this is a long edge, is longer than this edge. So it's only one edge and is a long edge that is discontinuous. Others are continuous. This one spans into this panel, this side spans into this panel, and this one spans into this panel. That is continuous slab. But for this other side, it is discontinuous. That's the meaning. Then for the panel number 3, you have two adjacent edges discontinuous. The same thing shows this discontinuous, two adjacent edges discontinuous. Okay, this one is supposed to be an interior panel. So I will double click on that. And here see more options. So you can as well change your panel configuration here. Like what I'm seeing here is an interior panel, and the software is telling me is 4 edges discontinuous. So I will not accept that. So I will select interior panel here, because that is what it is actually. Yes, that's good. So you can from here change the configuration of your panel if the software is not giving you what it's supposed to be. So the next thing we will do now is go to, okay, we will select the imposed load. So now when we calculated the imposed load, that's the self weight of the slab. You know, the slab thickness is 150. That's 0.15. So when you multiply it by unit weight of a reinforced concrete, which is 25, it gives you this. And in our model, we used a finishes of 1, which is 4.75. So I will put this as my imposed load, 4.75. Then my life load, 1.5. Yeah, the thickness of the slab, 150. Let's try 150 first. So if 150 does not pass, we can increase it. So I'll select the other ones and press Ctrl V, paste on all of them. So that's the load. So now come to settings, design parameters. You see this one is preferred span, effective depth. That's for deflection check. So deflection check ratios but simply supported 20, continuous 26. I'll just leave this one like this because it's to as per EN 1991 as we selected. Yes. So material property, concrete grade, you can change it from here. You can increase or reduce. Steel grade, change it from here. Concrete cover, you can use 25. Minimum thickness, okay. If you decide to reduce my thickness, which I know is not even possible. So rebar diameter, I will use a minimum of 10. Yes, that's good. So for rebar spacing, minimum of 150, shouldn't be less than 150. Don't need anything less than 150. Maximum of can use 200. So this is actually a slab. So if I want to use 150 by 150 for all my spacing, so I'll simply put 150 here. Yes. The slab doesn't really need much reinforcement, and that's why even if I put 300 there after design, I can even see a spacing of 300 in my slab reinforcement. So if you don't want to see such a thing, if you want to use a uniform of 150, just put 150 as maximum spacing, and it will just take 150 for everything. Yes, but for economy, you can use 200. It's better so I don't waste resources unnecessarily. So that's that. If you click on this spacing, it has already picked 150. Yeah, that's good. So rebar mark manager, in Eurocode we use H. Bar mark H. So we can use capital letter H here. That's that. Instead of T, you can use H. Bar H at that so and so center to center. So click OK. Click OK. Then you go back again to this for crack width settings. Perform crack width. I'll increase it to 0.3. So it will do my crack checks. So that's all for the settings. So I will now click on either I click on this green button here, auto design, or I click on design and select auto design. So you wait for the design to come. See, that's all. This green light here shows that everything passed. All the panel passed. That means our thickness of 150 is sufficient. That's good. So you can see concrete grade, slab thickness, steel grade, bottom reinforcement, and top reinforcement. Everything is H8 at 200, H8 at 200. So well, I can still restrict my if I don't want to use H8 here for any reinforcement size I want to see in my results. I can edit it in my settings. I can set it that when the software is picking reinforcement, it picks what I want it to pick. So if I want to use H12, I can do the settings, and at the end of the day I'll see H12 instead of H8. So let's just quickly do that. But before you can do that, I have to unlock the design. Yes, then go back to settings, design parameter. So we come here. I'll come here and uncheck this and this. So once I do that, it will no longer select any of this reinforcement diameter. It will not select that. Yes, then I'll come here. This rebar, of course, is 12 now. I can't select 10. So it's 12 now. So if I now go to rerun my analysis, you will see, click on this green button, I will see 12 all the way. Exactly. See 12. So in case you don't want to use H8 for your slab and the software is giving you H8, actually H8 will do the work. That's what it means, that H8 is sufficient. So, but if you are not that comfortable, you want to still use H12, that is what you do. Just do your settings like that, and you get what you want. Yes, then okay. Okay, there's another thing I'm forgetting to show you. I call this S1, S2, S3. That's the name of panels. I can as well edit it and call it panel 1, panel 2, panel 3. I'll quickly show you how to do that. So I will first of all unlock the design, unlock it, then I'll go to modify, edit slab description prefix, click on this, then prefix for slab mark, I'll type panel. That's good. I'll click on set. See, panel 1, panel 2, like that. And I'll click OK. If you look at this way, you see it has taken its panels. It's now using panel, panel, panel. That's what it's supposed to be. Then here it is also like that. So I'll click on design. That will not actually affect my design. So that's that. So the next one we were going to do now is how to harvest our reports. When you click on report now, let's check the text schedule. You can group similar. Do you want to group similar slabs? You can group similar slabs so that you don't have much thing there. This is text schedule, which you can export to AutoCAD. So you see slab schedule. This is a concrete strength, steel strength, level 3 meter. So you see slab mark, all the panel. These panels are similar. This one's similar. This one's okay. Slab thicknesses, then full length. Yeah, H12, H12, curtailed, a long short span, all those ones. So full length of this, that, a long short span. So top reinforcements, same thing. Yeah, it's okay. Then come back to design. I'll go again to general arrangement plan. If I click on that, it shows me the slab layout. Slab layout, even the columns are there, the beam numbering, everything. The software have done everything for you. Just clean it up, take it to AutoCAD, clean it up. So this particular drawing now can be taken to AutoCAD. So you don't need to even do your slab layout manually. You don't need to do it manually. Okay. So for me to export this to AutoCAD, I'll first save it as DXF. Click on save, this save button here. Click on it and wait for a dialog box to come out. Yes, that's that. I have to select the folder you want to save it into. Let me to save it into Staad.Pro. Double click on that. Then this file is in DXF. Yeah. So I will type slab layout. That's good. I will save. So if I want to open, let me just do that immediately. Click on here. If I double click this, it is AutoCAD file, and you can see it's AutoCAD file. While it's opening, let's get more of our output. So we go back to reports. Okay, the AutoCAD is up. Okay, so this is it. This is it. You can edit it. You can clean it up. You can delete. You can anything you want to do. So the thing is done already with grid lines, everything. What you just need to do is get a very fine template for your slab layout, and you just bring it here. You match properties. That's just what it means by cleaning up drawing. Match properties. Make sure it has the normal text height, the normal height, line weights and line types, and the normal scale you get. So the work is done already. These ones are the beam numberings and the beam dimensions. Yeah, that's that for this one. This is AutoCAD. If you do save it as AutoCAD file. You can save it as AutoCAD file, not DXF again, but it is still DXF. You can do save as an AutoCAD file. It becomes your AutoCAD file. So that's that. So if I go back again for implant detailing, this one will give us the detail reinforcement. Yeah, if you look at it very well, you see we have bottom reinforcement and top reinforcement. So it did it separately. This is separated. This one is top reinforcement. You can see all the at the continuous panels. We have top reinforcement. I'm going to do a video where I will explain the slab detailing. I'm going to explain slab detailing. I'm going to explain it from beginning to end, from scratch. I will do it manually so you get the full understanding of what it is. Because if you don't know the manual, yeah, there's no way you can understand what software is bringing out. So it's very necessary you know it as an engineer or a potential engineer. So this software separates bottom reinforcement from top reinforcement. As you can see, this one is bottom reinforcement and the other one is top reinforcement. So you can as well save this to, as we did, just click here, you save it again to DXF, you know. So maybe during the cleanup exercise, you can copy the top reinforcement and superimpose on the bottom reinforcement so that all of them will be in one drawing. Depends on you and whatever you want. But this drawing, I bet you would like to clean it up. Look at all this text, yeah. But you just need to clean it up. But your work is 70% done with this software. So it's very helpful for to us engineers. It makes my work very easy for me. Instead of doing work from scratch, you just do it, you know, with software like this, and you get your work done in a short time. Okay, that's that. Let's go again. We can extract slab section. Yes, we can also do slab section. So let's cut a section across this side. So let me see. Let's cut a section across here. So we have this place to be B18. Okay, that's good. So B31. Good. So I'll come back here and slab section. So this software can as well cut a section for you. Number of slabs, I have 1, 2, 3. I have 3 slabs there. Yes. So section mark, I'll just call it section A. That's good. So here it's asking me which panel is panel 1. Yes, panel 1, panel 2, and panel 3. Yeah, that's good. So now they have given me the LX and the LY of that panel. You get to I need to also put some things. Yeah, so this one is end. Yes, end. We're talking about here is end. So the left mark. Okay, this one is left support mark. What's the left support mark? So if you look at this beam here, is the support of the slab. So the mark of the support is B18. So I'll put B18 here. B18. That's left support mark. So left support breadth 225. Left support depth 450. That's how to cut a section, slab section, cut a slab section. Then right support is a continuous. You have a continuous here. Right support mark is B23. B23. Right support. I will just copy this one. Copy and paste. That's good. So you come to panel 2. Panel 2 left support is the same thing with this. No, left support for panel 2 is B23. So I'll copy this one and paste here. Yes, right support is I'm trying to locate the beam number of this place. I can't even see it from here. Okay, let's, since we have the AutoCAD already, it is okay. Beam 20 B28. Yeah, that's good. B28, B28. Then the thickness and the same thing. That's good. So the panel number 3 here is B28. B28. I'll copy this one and paste here. Yes, then the last one is B31. B31. I'll copy this and paste here. That's good. Yeah. Standard cutout drawing. That's good. I'll click on draw. Yes. You see, this is our slab section. So I can as well take it to AutoCAD. Can take it to AutoCAD. So I can save it to AutoCAD as a slab section. You can see slab section, slab section. So save and we open it. That's good. This is my slab section, so it has been done already. See the thickness of beam, beam there. See the dimensions, the top reinforcement, everything has been done. So we just need to dust it. Just need to dust it and nothing more. Section. This is how to cut a section with RCDC. It's very simple, very simple. Cut a section in RCDC. Section cut. Yes. We come back here. Yes, that's that. Then we can come back again to our reports. So the remaining thing is design summary. We can project settings are all about our inputs, what we put in the design. You can see for deflection checks, we have cantilever 8, simple supported, the rest of them. Containment locations are the inputs, preferred rebar 12 mm, concrete grade 12, 25, 30, C grade. These are the things we put in our inputs. So then for the report, Staad.Pro RCDC gives you a report. If you need summary reports, give summary reports. This is summary reports. You can see project name, duplex, client name, Mr. ABC, engineer name, engineer XYZ, as we put it in. So if you put your name here, your name is what will come out. The name of the client will come out here. So panel types have okay. So for panel 1, we have LY, LX, life load, imposed load. As we put the thickness is 150, span type is two-way, panel type is 4, design code is this, grade of concrete is that, grade of steel is that. This is summary, report summary. You see, summary of results. See, bottom reinforcement is this. These are the reinforcement, top reinforcement, and the rest of them. Distribution. Then that one is for panel 1, for panel 2. So this is summary of report. So if you don't need the design summary, you can go for detailed calculation, that's design calculations, to give you all the calculations. If you want to open only for panel 1, you can get only for panel 1. You can get only for panel 1. So it will not show any other panel because we have selected only for panel 1. Okay, these are our inputs. Then the design moment. Yes. moment coefficients and the rest of them, crack width, yeah, yeah, reinforcement, how it's being calculated. Yeah. So this is just the reports. Report, everything is okay. Everything is okay. See this one, slab is safe in the deflection. This is slab is safe in deflection. That's why it is like that. So that's that. If you check the crack width check, this one is for crack width check. Everything is alright. So if you want to do bill of quantity, it is still allowed. In the plan area, you have to put the plan area, calculate plan area, put it there. It gets you BOQ summary if you want to. So, but we're not going into that. You can as well do bar bending schedule. You can do the settings. If you have any special settings you want to make, you can do settings here. I think I will do a separate video on that, how you can use this to generate bar bending schedule. Then if you can just generate bar bending schedule, see how you can take it to Excel or AutoCAD, any one of them. We see how software is actually a wonderful software. This one is AutoCAD bar bending schedule in AutoCAD. So we can export this to AutoCAD and it becomes our bar bending schedule. You don't need to do it manually, So if you can, as you can see bar AB, cutting length for A, this is B, that's that. The same thing continues like that. Then this one gives you total weight in kg, rebar for all of them 12 mm. That's that. This is total length, total weight, length in meters, weight in kg. This total. So that's that. Very, 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 very interesting. So this one is for bottom. This is for top. This is for top reinforcement. So it is separated. So if you can do the combination if you want to. Okay, at this point we end here. The next class we are going to do beam design. We're going to design this beam with RCDC. Still take it to AutoCAD to get our reinforcements. Yeah, if any of our beam fails, we know how to make it pass. I'm suspecting this beam will fail, so don't miss the class. Let's see how we are going to resolve it. Let's see if we are going to resolve how we are going to resolve this beam that will fail. I know it will fail. Don't miss the class. Stay tuned and subscribe to my channel, share my video, click the like button and give me a positive comment. Thank you very much.